everybody. We are discussing the differential equation in that of the oscillation. In previous lecture, we have to discuss about the summary of oscillation. After that, we have to discuss about the differential equation in the simple harmonic motion. We have to discuss the simple harmonic motion in the previous lecture. Now we have to discuss about the differential equation of simple harmonic motion. First of all, we know that within the differential equation, within the oscillation, there should be we indicate that the force is directly proportional to the displacement of a particle. But there should be a direction of force and direction of difference are same in magnitude but the different in direction. Isn't it? Now we have to take the restoring force constant K in between this equation. We have to discuss about the differential equation of the simple harmonic equation, that is the force is applied on the particle and that the force is equal to the minus kx. It is given by the equation number 1. Isn't it? Now see here, if we know that the Newton's second law indicates that the force is directly proportional to the acceleration if there should be a mass is the constant factor. If mass is the constant factor, then F is equal to ma. F is equal to ma. There should be exist the Newton's second law is here. From this, we have to put the value in this equation 1. We have to get there should be the equation of Newton's second law is equal to the equation of differential equation. Here should be a minus kx. Means there is the ma is equal to minus kx. It is called as the equation number 2. Equation number 2. We know that the velocity of the particle, with the displacement x and with the t, there should be a v is equal to dx upon dt. We know that, and we have to see in the previous topic also. Isn't it? After that, we have to take in the acceleration of this. Acceleration is nothing but the derivative of the velocity. Isn't it? Means the a is equal to dv upon dt, and it's recognized that it is formed that d2x upon dt square. This is called as the common equation number 3. After that, there should be a substitute these three equations within the equation number 2. Which is the equation number 2? ma is equal to minus kx. This is the equation number 2. After that putting, we have to take instead of a, we have to take the acceleration, and there should be we have to take this differential equation is become, there should be a m d2x upon dt square is equal to minus kx. d2x m into d2x upon dt square is equal to minus kx. This is the equation. Now after that we have to simplify this equation. This term will be comes to this side and it became there should be a positive. There should be a negative. This became the positive here, and then we have to take and substitute the value of there should be in that of the equation k by m. K by m is the omega square. Then this equation 4 became d2x upon dt square plus omega square x is the differential equation of the simple harmonic motion. And which we have to calculate differential, and this is called as the linear differential equation of simple harmonic motion. Then this expression of we have to discuss about the differential equation of the simple harmonic motion. And there should be a question arises that deduct the differential equation of simple harmonic motion or the particle performing the simple harmonic motion. Whenever there should be a question arises like this, we must have to write this differential equation. After that, there should be another question arises on that there should be a calculate the acceleration, velocity and displacement of particle performing simple harmonic motion. We know that. Then taken the 5 numbers equation here. Which is the 5 numbers equation here? d2x upon dt square plus omega square x is equal to 0. This 5 numbers equation. And this again simplify this means this omega square x term taken to this side, and then there should be a d2x upon dt square is equal to minus omega square. This becomes the omega square. From the equation number 3, we state that there should be a value of d2x upon dt square is nothing but the acceleration here. Means after the putting that the acceleration, we get the value of acceleration, and this is the value of acceleration is nothing but a is equal to minus omega square x. This is the value of acceleration. After that, we have to take up the simplify this equation. The simplify this 5 numbers equation, there should be a d upon dt, dx upon dt is equal to minus omega square x. But we know that there should be a dv upon dt is equal to minus omega square x. Means that dv upon dt, put the values of dx upon dt and is equal to minus omega square x. On the simplification of putting the substitute value of dx upon dt is nothing but the value of velocity. We have to calculate the acceleration here. We have to calculate the another velocity is here. Velocity is here. V is equal to, there should be a dv upon dx is equal to minus omega square x. Minus omega square x. There should be a rearrange the same term. After the rearrangement of the same term, there should be a this equation number become the v dv is equal to minus omega square x dx. Minus omega square x dx. And this is called as the equation number 6. This is called as the equation number 6. On integrating the equation number 6, we have to take up the integration of dv is equal to minus omega square x integration of x dx. Now, on the integration of this equation number 6 is integrated. On the integration of this, the integration of velocity v dv is equal to v square upon 2 as like as the x raised to n. X raised to n plus 1 upon n plus 1 like this. There should be a, we have to take in the integration of velocity here. After that, the minus sign as it is, the omega square is the constant factor, and then the integration of this is should be a x dx x square upon 2 and plus there should be a c. Plus c is indicate that the constant of integration. But on the evaluation of this, we have to take on the extreme position of the particle. We have to take on the extreme position of the particle. At the extreme position of the particle, the acceleration is maximum and the velocity is become 0. Velocity is become 0. Isn't it? Okay. Now, put in the value of velocity v in the equation number 7 here. Equation number 7. Which is the equation number 7? V square divided by 2 is equal to minus omega square x divided by 2 plus constant of integration c. Then after that, putting the values of this, we have to take on the x is equal to displacement is nothing but equal to the acceleration at extreme position. What is it? The displacement. How much the displacement is takes place? There should be a displacement is takes place as though there should be equal to the acceleration is there. At which condition? At the extreme position. Now see that after the putting the values of this equation in 7, we have to take in the value of constant of integration c. After that, we have to take up the constant of integration c is equal to omega square a divided by 2. Omega square there should be a divided by 2. Then we have to calculate the equation number 7 is here. Equation number 7 is here. After that, put the value of c. Put the value of c in that of the equation, which is the equation become v square upon 2 is equal to minus omega square x square divided by 2 plus omega square a divided by 2. Omega square a divided by 2. We have to calculate the velocity of this. We have to calculate the velocity of this. On simplifying this equation, we have to take up the v square is equal to omega square. There should be a square minus x square. Now there should be a, this is the value of v square. This is the value of v square. After that, we have to take up the taking the square root of this. The v is equal to omega into under root of a square minus x square, and this is the values of the velocity and the extreme position. After that, we have to discuss about another topic is remaining. There should be a, we have to discuss about the how the equation of or the there should be a covering equation of this displacement will be taken. Then substitute v is equal to dx upon dt. V is equal to dx upon dt. Then equation number 8 become. Equation number 8 become, there should be a dx upon dt is equal to which is this equation, omega into under root of, there should be a square minus x square is there. A square minus x square is here. Now again integrating this equation, we have to take up, there should be a dx upon under root of a square minus x square. First of all, we have to simplify this equation. Omega into dt. On integrating this equation, again integrations will be explained. There should be a integration of dx upon under root of a square minus x square. A square minus x square is equal to, there should be a integration of omega dt. Omega is, here should be a constant factor. After that, we have to take up the integration of this is nothing but the sine inverse of x upon a. Sine inverse of x upon a is equal to omega t plus phi. Phi is the again constant of integration, and phi is known as value of x at any instant of a. बराबर है, phi is the constant of integration and value कशाचे आहे, value of, there should be a x म्हणजे काय, value of displacement at t and t time, isn't it? Okay, now there we have to take up, if there should be a, we have to take up at the t is equal to 0. If we have to take up this equation become at the t is equal to 0, we have to calculate the at t is equal to 0, at t is equal to times t is equal to 0, then we have to get the equation x is equal to a sine of omega t plus phi. And this is the general expression for the displacement of displacement x. This is the general equation for the displacement x, and if there should be a particle performing the simple harmonic motion at time t. Now see, we have to take up there should be a at time t, and this is the find the expression of particle. There should be a, we have to discuss about the differential equation of the simple harmonic motion at time t. You see here, which is the equation? There should be a x is equal to a sine of omega t plus phi, isn't it? Okay.